Let's continue looking at stationary point and their nature. Stationary point, otherwise called turning point. All right. Now, let's look at an example of a function, right? And we're going to find out where the stationary point is and the nature of it. We have y equals x squared minus 2x minus 3. Question. Let me type them. Find the location of the, let's call it SP, the stationary point. Determine the nature of the SP and sketch the curve. All right. So here now, let's make this writing a bit smaller. All right, we want to find the location of a stationary point. Well, you know that at the stationary point, the gradient is 0. How you find the gradient is to differentiate the function. So, what we do is find dy by dx is equal to 2x minus 2 using the power rule. And at the SP, at the stationary point, dy by dx equals 0. So 2x minus 2 is equal to 0. Now, if we transpose, or if we solve for x, 2x is equal to 2, we add x to both sides, and then x is equal to 2 divided by 2 equal 1. Alright, so the stationary point occurs where x is equal to 1. When x is equal to 1, that's where the stationary point is. Alright, now, we want the location of the stationary point, so we should find the y value as well. So we get the coordinates. So y is equal to 1 squared minus 2 by 1 minus 3. 1 squared is 1, minus 2 is 2 minus 3. 1 minus 2 is negative 1. Negative 1 minus 3. Negative 1 minus 3 is negative 4. Alright, so there you have that. So, therefore, we can say the SP, the stationary point, is at 1, negative 4. X equal 1, y equals negative 4. Now, that's where it's located. But what's the nature of the stationary point? What kind of stationary point is it? Alright, let's erase some of these things, and we are going to look at the nature of a stationary point. Now, at the stationary point, we have x equals 1. Now let us see if we can find out what, alright, we know that y at 1, when x is 1, we can imagine we have a x-axis here. When x is 1, y is negative 4. So this is where we're at. 1, negative 4. And we have a line. Let me draw a straight line. An imaginary line here through 1, negative 4. Now, if we go to the left of the point and we find out that to the left we have a higher value than negative 4, and to the right we have a higher value than negative 4, then we have a minimum point. if we go to the left and find a lower value than negative 4, and on the right we have a lower value than negative 4, then what we would have is our maximum point. Let's see what's going to happen. We choose a point close to 1. Let's say we have x equal 1 right here. This is 1. Let's say we go to negative, no, not negative. We are at 0.9. Nice. Right here is 0.9. To the left and to the right, we choose a point here, 1.1. We're keeping it safe by choosing a point close to 1, because some graphs, you know, are like this. A graph might be like this, and our stationary point is here. And if we choose a point too far, then we might choose a point above our stationary point or below our stationary point, and we make a mistake there, right? Some graphs are like this. But we can be safe in knowing that this graph is not like this, but this is more general. But for safety, we still choose a point close to our stationary point. Now, when we are at 1, our y value right above here, well, our y value is below, so it's 1, and below it would be below the x-axis. This is our x-axis. It's at negative 4. Now, let me erase part of this work that we did earlier. Alright. Now the thing is, what is y when x is 0.9? When x is 0.9, what is y? Let's see. Let's reach for our calculator. 0.9 squared. This doesn't have a direct square on it, so I choose to the power of 2. 0.9 to the power of 2 minus 2 times 0.9 minus 3 equals negative 3.99. Alright, so to the left we have negative 3.99. Negative 3.99 is higher than negative 0.4. What happened to the right at 1.1? What do we get? Our calculator again. Let's clear our calculator. 1.1 squared minus 2 times 1.1, substituting based on the equation up here, minus 3 equal negative 3.99. So at 1.1 we have negative 3.99, which is still higher. Now if we were plotting between these points, we would go from negative 3.99 down to negative 4 and back up. So what we have here is a minimum point. So we can safely say our stationary point is minimum. So the nature of our stationary point is minimum. Nice. So it's located at 1, negative 4, and it's minimum, not maximum, minimum. So let's sketch the curve. We want to get an idea what the graph looks like. So do we do a little sketch of the curve? Let's say we have our x let me draw our x-axis and our y-axis a bit thinner than that. Alright, we're going to sketch the curve. We know that at 1 we have a minimum point, so we have something that looks like this, and it's the minimum point is beside -4. If we should look at that minimum point, it's beside -4, and this minimum point is right below 1. That's 1. Good. Since we want to sketch the curve, we can say where does the curve cut the x and the y-axis. Right? Sketching the curve here is a bit of work. So we want to know when x equals 0, what is y? Well, 0 squared minus 0, y is -3. So we see -3. That's what I'm here. Oh, my curves start to look a bit shaky. But anyway, and then to get these points now, what you could do is use the quadratic formula. X equal -b, so x equal -b. Our b is -2, so -2 is +2 plus or minus the square root of b squared, which is -2 square root is 4, minus 4 by 1. 4ac is 4 by 1. This is 4 by -3, 4, -12. Right? 4 by 1, which our a is 1, 4ac. 4 by 1 is 4 by -3, which is -12. And this will amount to plus 12 over 2 by 1 is 2. So it's 12 and 4. 12 and 4 is what? 16. So what we have is x is equal to 2 plus or minus the square root of 60, which is 4 over 2. So 2 plus 4 is 6 over 2 is 3. And 2 minus 4 is -2 over 2, -1. Alright. So what we would get here, 2 minus 4, let's check again. 2 minus 4 is -2 over 2, -1. Alright, so we see that the curve cut the x-axis at 3 and -1. Alright, so if you were to sketch the curve, it would look something like this. Now, question is, what if we should plot this curve using the computer? Would it look like this? Let's see. This is y equal x squared minus 2x minus 3. Alright, we have GeoGebra here. And x squared, x to -2, minus 2x minus 3. Was that it? Let's see. X squared minus 2x minus 3. Right, x squared minus 2x minus 3. And go. Let's make some adjustment to our curve. Yeah, the color is okay. I want it to be thick and I want to see the equation. Alright, x squared minus 2x minus 3 is our curve. Let's see, let's get a closer look. It cuts at -1 and 3. Right, cut at -1 and 3. It cuts the x-axis at -1 and 3, right? The y-axis it cuts at y equal -3. Good. And the minimum point occurs beside -4 and below 1. Beside -4 and below 1. Right, so we got our curve correct, and it is indeed a minimum point. So that's that for our equation here. We found the nature of the minimum point, the location and the nature of the minimum point. Another thing we want to look at is this. What is another way of finding the nature of the minimum point? We'll look at that in another video. This video has gone long enough, so we'll continue looking at this same problem, but we'll look at another way to find the nature of the minimum point in another video. So I'll see you then.